Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Xyratex. We have Eric Lomascolo. He is a Director of Solutions Marketing at the company. So, Eric, welcome to the show today.
Thanks, Rich. Great to be here.
Well, great. Thanks. I'm glad you could join us. We're curious to find out what Xyratex has up its sleeve here for ISC 12. So I've brought your slides up. Let's start with that, and we'll follow it with Q&A.
Great. Appreciate that, Rich. And, just opening up here with you, we're going to be there at ISC. We will have announced our ClusterStor 6000 at the time of this broadcast. And at ISC, we're going to have a new ClusterStor 6000 system on the floor for all the attendees to see and come talk to us about and get some demonstrations of what we're announcing and what we're going to be talking about here with you today. ClusterStor 6000 is designed to deliver the ultimate in HPC data storage for our HPC users out there in the industry with optimized time to productivity. And what I mean by that, Rich, is around efficiency, which there's multiple areas of discussion in terms of efficiency that we target with ClusterStor 6000, specifically floor space, reduced cooling, ensuring performance meets the efficiency needs of the application itself, and its management, its overall ease of deployment, management, and maintenance of the system over time. So all those facets go into ensuring that we get the best use out of the time in an HPC environment. And then there's application availability to ensure overall capabilities within an HPC framework. The idea is to keep the applications running and doing the science they're meant to do as much as possible without any impact to the application or the actual compute processing that's going on. And storage throughput is certainly key to that overall availability theme. So with ClusterStor 6000, as many people may know Xyratex as being a provider to OEMs in the enterprise storage space, we're bringing to the table all of those capabilities, the enterprise heritage that we have as a part of what Xyratex does. So when it comes to reliability, availability, and serviceability, we've got that licked, and we've really are bringing that forward here with the 6000. And then, of course, the actual results, the performance that delivers those results, keeping, as we talked about before, the availability of the system to deliver those results. More and more, it's all about ensuring we get the best return on investment for all of the compute and storage infrastructure that we have. And that's what the ClusterStor 6000 is capable of doing. If you remember last year, at about the same time, we introduced our ClusterStor product line, and since then, with ClusterStor 6000, as we go to market here, we are now delivering 2 times the performance that we delivered last year with our first entry to the ClusterStor product line being the ClusterStor 3000. So the 6000 here is now raising the bar yet again and doubling that performance overall. And then, like I said before, in terms of reliability, availability, and serviceability, we're bringing all of that capability that Xyratex has been known for to the HPC storage solution, the data storage solution. What I just want to go over here is what areas of requirements the 6000 solution addresses in the space. So the requirement for faster data throughput and capacity. Of course, it's always growing. We know that from a compute capacity perspective, but it's also from a storage and data throughput perspective. This is just growing as fast and is also chewing up data center floor space as fast as it's growing. And so then also, talking about the compute capacity, there's always that need for that increasing of compute capacity, but how we're going to feed those processors, those cores, with the data is certainly part and parcel. These two are interconnected, of course. And then also trying to get into more efficient systems deployment and management. As these systems grow, they require more components, more devices, more space on the floor. It's really going to be all about relieving some of the burden for the systems administrators, the cluster administrators, and making it easier to deploy those, making it faster to deploy instead of weeks, getting it down into hours for that deployment. But then also the management itself and the maintenance of the system. When we're talking these large systems, you need to always keep an eye on the performance of the file system and also all of the health of the overall solution. So it's about reducing the time that it takes to find issues and resolving them quickly so that we can keep the system running. And then we talked about this before. More and more of the HPC solutions that are being deployed are requiring these higher levels of system availability. We talked about getting greater returns based on the investments we're making in the compute and storage capabilities, and that means these systems have to stay up longer and be more available for the science that we're doing to achieve the results we're looking for. And in the next slide, these go hand in hand. These are some of the constraints that we're dealing with as we're trying to grow and we're trying to build these HPC environments that are faster, year over year. We're also having to deal with some of these constraints that are on the table. The budget's continuing to shrink. The investment money, the dollars that would go towards it, being looked at very carefully. And of course, we talked about the return on those investments that we do make. The limitations in power resources. Of course, as we start to grow these environments, more compute going towards the petascale computing here, we're really looking, as we move petascale, exascale, at really consuming all of these resources, the power resources, at a much more phenomenal rate. So how do we get this addressed? There's limitations in certain countries even. I think in the EU there's limitations on how much any given data center could draw from the power grid. So that all has to be dealt with as we load out our HPC environments. Hand in hand with that is the actual data center infrastructure itself. How do I make use of the infrastructure I already have, the building infrastructure? Do I need to build new? Can I use what I have? The cooling that goes along with the increase in power and capability to compute. We have to deal with that as well as all of the cabling infrastructure and all the power infrastructure inside those data centers. This is an overview, Rich, of the ClusterStor 6000 solution and how we've deployed the ClusterStor architecture into the new 6000. It's an integrated and scalable HPC data storage solution. So we'll talk more about its scalability from small to large, but it's integrated in a way that you deploy, use, and manage this as a single system. And all of that, as we talked about before, the need to relieve the burden of deploying these types of systems, all with the mind of making this easier to use. So the diagram on the right is really meant to illustrate the different types of components that we have pulled together, integrated into this one single architecture. So from our own Xyratex hardware, our OneStor integrated application platforms that meld storage and server capability into this one platform for the file system, the operating system, the RAID data protection, and the management framework. And then at top, the management, which interconnects with that management framework called ClusterStor Manager. So this one view over the entire system, whether it be a small system to start with or scaling out to the very large in terms of capacity and performance. One view with proactive monitoring, real-time monitoring, and drill down views into any issues that you may have within the health of the system. So all of that, again, back to what we discussed at the outset around ClusterStor 6000, all of this is meant to deliver efficiencies in multiple areas, application availability through the reduction of all of that complexity within this architecture, and all delivering that with massive results through the performance that's delivered in ClusterStor 6000. So the next slide that we have is from Jacques Charles from CEA. He's the Chief of Services there, and they've been working on their Exascale I/O prototype for the last 3 to 6 months, and they've been using our ClusterStor 3000 product in that space, and up to this point have been very happy with the performance they've seen, and certainly with the ease of installation and management that they've seen with the solution. And of course, because they're always looking to increase the performance in that type of environment, and for this particular prototype, they're looking forward to the new ClusterStor 6000 that we're talking about here today, which, as we'll show you later, will provide them with very significant increases, 2 times increases in terms of file system performance. What I wanted to do here was just talk a little bit about the architecture a bit more. The Xyratex architecture that's been applied is parallel in nature. It's all built to scale out from small to very large in terms of its overall I/O architecture, but as it scales to also ensure that we're not dealing with all of the traditional components that would require complexity or require much more on the floor than what ClusterStor would provide. And I mentioned before, ClusterStor 6000 delivers all this with the technologies that we have, our application platform technologies, as well as the Lustre integration that we've done as part of this overall solution. Applying all of the experience that we've had for over 25 years in the storage space, and the experience that we have is having Lustre capabilities, development and test capabilities on board here at Xyratex. So we've created in ClusterStor 6000 this optimized hardware and software solution where we've taken the operating system pieces, the data protection pieces such as RAID, and all the Lustre file system pieces, and we've melded that, optimized it for our application platforms to create this solution as a fully integrated solution, as we've mentioned before. So when our OEMs take on this capability, this architecture from us, they're able to take this in and know that everything that gets shipped to them are factory tested. And what I mean by factory tested for us is multi-layer. We start with the actual component levels, working up into the system level, where we have rigorous acceleration testing at the front end of our manufacturing process that reduce the actual AFRs on hard drives, and also checks for any kind of system anomalies before the system goes into the next phase, which is actually building the entire ClusterStor 6000 solution. So after it gets into that solution state, we then also move into long-term workload testing, for weeks to ensure that we have eliminated any possibility of DOAs when the system ships. Certainly, we're not going to get rid of everything, but the idea here is to ensure that everybody can get up and running quickly and they can start production as quickly as possible without any downtime to their project. And all of this is done in such a way that when it gets shipped to the customer, all they have to do is literally roll the racks out of the crates, plug them in. File systems are ready to go, ready to be fired up and connected into their compute infrastructure. And we're going to talk about this a little bit more, but all of this that we're talking about here result in this increased file system throughput. The architecture itself, the attention to detail, and the way we've architected and designed and manufactured the system, all of the testing, all of that has resulted in this increased file system throughput and capacity capability and efficiency on a per rack unit volume basis. And what that means, literally, Rich, is reducing the footprint to deliver the performance that you need. On the next slide, we go into a little bit about the building block here that makes this all possible. It's our scalable storage unit. And for ClusterStor 6000, we've tested this at 6 gigabytes per second of file system performance. So that's IOR performance. And so we've gotten up to that performance for every scalable storage unit. And we are now taking this to support installations of up to 1 terabyte per second of file system throughput. My note here that I want to make here is that certainly we can deploy different types of storage and achieve the same performance, but I want to go back to that other statement, which is efficiency. How much floor space are we going to need to deploy that same performance? Is it going to be my whole data center floor, or can I do it in a third of the space, for example? How do I get there? How fast? And ClusterStor 6000 makes that very efficient. And of course, scaling the capacity of the solution as well from tens of petabytes, from small installations up into tens of petabytes of storage capacity. On the next slide, I just get to a little bit more of the physical detail here. Each of the scalable storage units are what we call the SSUs, each one of them, again, producing 6 gigabytes per second on an IOR basis. As our customers scale out this storage solution, they simply add the SSUs to grow their storage capacity as well as their performance in a linear fashion. And as I mentioned before, our ClusterStor 6000 is already doubling our SSU performance from our ClusterStor 3000. Each of these SSUs include an embedded server module. You'll see there in this picture, the bigger picture on the bottom here, that these embedded server modules sit up atop the fans. They're labeled in purple here on this screenshot, and they sit side by side one another. And so we have 2 modules here for high availability. So when we deploy ClusterStor 6000, you are deploying a fully integrated storage system with file system server capabilities built in with RAID data protection and management framework. So for instance, if I start to scale into a single rack with 7 SSUs, I'm literally bringing 14 data storage processing units to bear for my Lustre file system. This holds increased performance over our ClusterStor 3000 product. So we're leveraging the latest processor technology in our application platform, double the memory, and also we're bringing FDR InfiniBand to the table with Cluster 6000. On this next slide, I wanted to outline what this performance means and where we see it fitting. So when we introduce ClusterStor 3000, you'll see the performance on the y-axis in terms of file system gigabytes per second. This is not block level performance. This is file system, the end application file system performance. On the x-axis, we're talking about the numbers of scalable storage units. So the component, the building block that we just talked to you about, and the number of those to deliver that file system performance. So where before, in order to provide the performance that we needed for 180 gigabytes per second, if we look at the chart here, for ClusterStor 3000, we would have needed to deliver 60 scalable storage units for that performance. Versus our new ClusterStor 6000, which can do that in half the SSUs. So 30 will get you to that 180 gigabytes per second. So just track the lines here, the ClusterStor being the top left-hand, ClusterStor 6000 being the top left-hand line, and the ClusterStor 3000 being represented by that middle line. So what we have here is, since the SSUs are capable of holding the same usable file system space, 192 terabytes per SSU, that's usable file system space. It's the same for the 3000 as it is for the 6000. So the choice becomes, am I more primarily interested in capacity as I grow into performance? If I am, I would more than likely choose 3000 to grow my capacity equally to adding performance. If I'm more interested in performance and getting that into the smallest footprint possible, and I'm not so concerned, I have smaller data sets, so I'm not as concerned about capacity, I'm going to move more towards ClusterStor 6000. So moving to the next slide, I just wanted to talk about the 3000 to 6000 upgrade for those that might be interested in increasing their performance. So we introduced ClusterStor 3000 last year. Those customers that want to move up to the 6000, they have the capability of maintaining their investment with the chassis and the drives through this architecture. So when we introduced ClusterStor 3000, like I said, we announced that with 2.5 gigabytes per second of file system performance, great deal of performance in the footprint as it were, at that time already beating out competitive storage products out in the market at that time. The embedded server modules that we talked about before, again, there's two of them here within the SSU. At that time, they were QDR-based InfiniBand. You'll notice here that the server modules are outlined and they're labeled blue, so they're a bit different. And the QDR InfiniBand was actually through a PCI interface for the 3000. If we move to the next slide, you'll see a lot of what we talked about earlier on the top with regard to the 6000. But specifically, as we speak to the upgrade and what you get from that, on the right-hand side, you're going from a QDR InfiniBand base to an FDR InfiniBand, and that's InfiniBand embedded in the board on the actual embedded server module itself. Or you can choose 40 gigabit Ethernet. Again, you're also doubling that performance, so moving from 2.5, 3.0 gigabytes per second of file system throughput to 6 gig per second. All while you're keeping the storage that you purchased when you purchased the 3000 and all of the SSU chassis that you've already invested in. Finally, with regard to management and reliability, availability, and serviceability, it's a key component. We talked about certainly how we build an enterprise solution here in this architecture with hardware that is designed for the enterprise. So higher levels of availability. You saw our high availability server modules as part of each of the scalable storage units. But also key to all of this is how we manage the system, the efficiencies, but also how I can find any kind of issues that might be going on in the system. So ClusterStor Manager takes advantage of that distributed management framework that we have throughout the ClusterStor architecture and allows us to bring all of this into the ClusterStor Manager as a single system instance. So whether I have one scalable storage unit, 30, 60, 90, on up, all of those are looked and viewed as a single system within ClusterStor Manager. And the unique difference here that needs to be looked at is how we're able to deliver this management from the file system all the way down into the hardware platform and architecture. So if there's any issues at the file system level, we'll be alerted through real-time monitoring, and we can literally drill down as far as that issue may go. Is it down into something that's going on at a data protection level? Is it something at a hardware level where we need to replace a hard drive? All of that we can drill down from any top-level alert that we might receive. And on the final slide here, Rich, it's just a summary of how ClusterStor 6000 addresses each of these areas, what we've talked about in the earlier slides. So the ability to provide that faster data throughput and capacity, so a very high density storage application platform is part of our scalable storage unit, gives us the density that we're looking for to reduce the footprint, but increase the performance and productivity through the system. And then increased compute capacity enablement. Certainly, while we don't add compute, we do certainly service the compute with the file system throughput and its productivity of reading information as well as in terms of performance of writes. And then the efficiency of systems deployment and management with our ClusterStor manager, and then the higher levels of system availability that we provide with ClusterStor 6000. So with that, Rich, that's the end of the main content here with the slides that we have. I'll open it back up to you, sir, for any questions.
Oh, great. Well, thanks for that, Eric. You know, I'm curious about that processor that you guys are using. What essentially is that doing? Is it like buffering data so that it can stream out fast, or what's its main function?
So you're speaking of the scalable storage unit?
Yes.
Yeah. So that's a great question. It's doing quite a few different things that would normally be split up in a traditional Lustre deployment with multiple servers and RAID controllers. So there's two levels of integration that we've got going on here to simplify, remove the complexity, and create that file system performance for Lustre. So the scalable storage unit is literally integrating those file servers for Lustre along with the RAID, what would otherwise be in a separate set of RAID controllers into RAID functions, embedding that on those server modules. And then the second level, so we've reduced the hardware footprint there alone just by 50% by removing all of the RAID controller requirements and the separate file server requirements and integrating that into the server modules. Then the second level of integration takes all of that, puts them into this application platform that we have, marrying that up with the drives. So the scalable storage unit here is a 5U high-density rack unit chassis holding up to 84 drives in the system. Each one of these having 192 terabytes of storage, usable storage for file system performance. So each one of these is a balanced building block that can be loaded out. And what I mean by that balanced building block is we don't now run into those same challenges that we did with traditional storage architectures where we could have bottlenecks through those RAID controllers. So here, every time we want to increase our performance and capacity, we're also increasing our file system processing capability as well as our data protection capability.
So Eric, if someone were to ask you about what differentiates this solution, how important a factor would be the ClusterStor management software? What would you say?
Very critical factor in especially as we talked about earlier, Rich, the explosive growth that's going on in these HPC data centers. When you start to grow to that scale, the burden of keeping these systems running and ensuring that all of the components in your overall solution is working is very critical. So we see this. We see ClusterStor Manager as a unique differentiator that needs to really be looked at. Like I said before, it's giving you that full system view. Whereas when we were talking about that traditional implementations, I'm going to have to manage my storage RAID controllers separately, managing each one of my file system servers separately. Certainly. I might be able to find some point products that can manage some of these things for me, but at the end of the day, I'm going to have multiple multiple points of management. Whereas with ClusterStor Manager, I'm bringing that all into a single pane of glass and being able to drill down to any level of detail and get right to being able to see how I'm performing, as well as checking the health of the system or taking action on any kind of issues I may have.
Well, terrific. Well, Eric, kind of a wrap-up question here. Out at ISC, I assume you're going to have a rack of these devices out for display, correct?
Yeah, so we're going to have a rack with some ClusterStor 6000 in it, so you'll be able to see it up close. We'll also have a scalable storage unit sitting outside the rack, so you can spin it around and take a look at that. And then also we're going to have live demonstrations of ClusterStor Manager and how easy it is to use and how you can look into every facet of the system.
Well, it sounds great. Well, Eric, hey, I want to thank you once again for coming on the show today.
Rich, thank you for having us.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.